Hi, I'm Cormac McGuinness. I'm the Physical Sciences Course Director. I'm going to talk to you about the Physical Sciences TR063 entry, which can lead to degrees in physics, physics and astrophysics, and nanoscience. So what is physics? Physics can encompass everything from the emission spectrum of hydrogen, shown up at the top, atoms, electrons in atoms, quarks, the constituents of protons and neutrons, electromagnetism, giving us light, lasers, the interaction of light with matter, so semiconductors, materials, whether they're nanomaterials, nanoparticles, energy in all its forms, the structures of crystals, solids, everything, as well as the structure of the universe in terms of galaxies, stars, and planets. And then our degrees will also encompass topics such as quantum computing. So why study physics? If you want to find out what we know so far about how our world works at the most fundamental level, find out how this knowledge has been or can be applied to make our lives better, learn how you can make new discoveries and bring forth new understanding, learn how you can apply science to develop sustainable lifestyle on this planet, or the best reason of all, if you simply enjoy physics, that's a good reason to study physics as your degree. So there are 4 physics degrees in Trinity College Dublin. Within the Physical Sciences entry, TR063, you can emerge with degrees in either physics, physics and astrophysics, or nanoscience. And then the parallel theoretical physics entry, you can emerge with a degree in theoretical physics. In the first 2 years in physical sciences, you take physics and mathematics, as well as a third subject such as chemistry, geosciences, or biology, choosing in your final 2 years the degree option of either entering into physics, physics and astrophysics, or nanoscience. In terms of the number of places available in the physical sciences course, we admitted 72 students in 2020. And then as these progress into the 3rd and 4th year, we expect 30 or so to progress into their physics degree, 24 into physics and astrophysics, and 16 into nanoscience. The points for entry in the last 2 years have been in the range of 500 to 509, but we did admit in the last round one student with 477. But the average of the entrance into our degrees in physical sciences is 531 points. The subject requirements are very simple. You have to have 2 H4s or better in 2 science subjects, preferably physics and mathematics. But if you're seeking to enter from one of those schools in Ireland which doesn't have physics for Leaving Cert, then don't fear, you can still enter. In theoretical physics, the subject requirements are a bit more stringent, and they'll be discussed later. All of our degrees in physics degrees are 4-year degrees with what are called 60 credits in each year. And our first 2 years are referred to as the freshman years, the last 2 as our sophomore years. Within physical sciences, 40 of the 60 credits are physics and mathematics in the first 2 years. And then as you go into 3rd year, you choose to enter either into physics, physics and astrophysics, or nanoscience, where in the 3rd year there's 40 core credits, and then there's a selection of open modules or Trinity electives that you can choose from. And then in your final year, there's 20 credits of your final year is your capstone research project, where you'll be doing a research project either in your physics or physics and astrophysics or in nanoscience, depending upon what degree you've chosen. I'll just note that you can only enter into the nanoscience degree in the last 2 years if you've chosen chemistry along with physics and mathematics as your subjects in your first 2 freshman years. And there are some places in the nanoscience course which are reserved for students entering into chemical sciences who then choose physics as their 3rd subject. So a third of your time in the first 2 years in physical sciences is studying physics, a third studying mathematics, and a third choosing from among the open modules among the other science subjects available. So the core of the physics you study, the foundation of all of your physics degrees, includes light, electromagnetism, special relativity, classical and quantum mechanics, thermodynamics, materials, nuclear physics, astrophysics, waves and optics. where you'll learn experimental methods as well as data analysis and basic coding, learn to communicate physics to one another, and statistics, where you'll learn these through lectures, tutorials, e-learning assignments, experimental labs, as well as group projects. This is shared, these core or foundations of physics are shared with the theoretical physics students in the first 2 years. Of course, mathematics underpins all of this, and then you'll augment this with your choice of modules in chemistry, geology, or biology. So in each semester of each year, you take 10 credits of physics and 10 credits of mathematics, and then 10 credits of the third subject. In your second year, the pattern is somewhat similar, but it's not a pick and mix. Instead, you have to choose modules of your third subjects which continue from first year into second year, and no matter what pattern, whether you take all chemistry or all geosciences or all biosciences, you can progress into degrees in physics and astrophysics. But if you wish to progress into a degree in nanoscience, you must take chemistry for the first 2 years. So what are the 3 final degree options there? Physics, and this gives you the broadest training in experiment theory and computation. It spans all of quantum physics, nanoscience, semiconductors, magnetism, optics, lasers, photonics, stars and galaxies, as well as nuclear and high energy physics, quantum optics, energy science, and computational physics. Or you can specialize in physics and astrophysics, where in addition to the core physics topics, there will be an emphasis on astrophysics techniques such as observational astronomy, space science, learning more about planets and exoplanets, stars, galaxies, cosmology, and general relativity. Or nanoscience, where you'll apply your combined physics and chemistry knowledge to materials, nanomaterials, future nanomaterials, and you'll be lectured in modules in nanoscience, nanodevices, nanoparticles, how to grow these, how to synthesize these, polymers, photochemistry, electrochemistry, photonics, lasers, solar cells, and energy materials, among many other topics. In years 3 and 4 of all of our degrees, there's a common core of advanced level foundational topics of quantum mechanics, what's called statistical physics and condensed matter physics, as well as a whole host of specialist options which vary from one degree to another as to what you can choose. But there is a lot of choice. In all of your degrees, the capstone final year research project is 9 weeks full-time embedded with a top research group, either here in Trinity or elsewhere in Ireland, or in a variety of other partner institutions worldwide. In your third year, you'll take at least 1 or if not 2 Trinity electives to broaden your education. This is in addition to the history and ethics and philosophy of science. You'll choose a Trinity elective many of which address key societal challenges or are language and culture modules. In your physics degree, you'll enter our doors, you'll participate in our laboratories, in our tutorials, you'll learn your basics, foundational physics, you'll learn everything from stars and galaxies to planets to high energy physics to photonics to optics to nanoscience, nanoparticle growth, thin film materials, energy science, magnetism, superconductivity, and computational physics. In the physics and astrophysics degree, then the emphasis is much more on observational astronomy, the sun, stars, galaxies, the universe as a whole, gravitational radiation, cosmology, as well as other techniques such as radio astronomy, such as the radio telescope at Burr, which is pictured here. The nanoscience degree forgoes all of the high energy physics and all of the astrophysics. Instead, you'd be looking at, in the third and fourth year, you'll be looking at topics such as materials and material science, nanomaterials such as graphene, advanced materials characterization, advanced materials growth, nanoparticle growth, the properties of nanomaterials, as well as how to computationally model these, and energy science as well, or energy materials. The theoretical physics degree complements our physical sciences degree, and it'll be described in a different talk. So why choose physics in Trinity College Dublin? Well, because our environment, our history, there's 3 centuries of physics embedded in Trinity College Dublin, and of course a Nobel Prize winner in Ernest Walton. But it's also the largest physics degree program in Ireland, graduating 90 plus physicists across our 4 degrees in each of the last 2 years, and perhaps more than 100 physicists this year. It has the largest physics research funding in Ireland, the highest ranked physics and astronomy department, also has the highest ranking for material science. So you'll be taught by world-leading physicists here. The skills of graduates from our physics degrees incorporate the Trinity graduate attributes and provide the skills necessary for lifelong learning. But in particular, from our physics degrees, our physics graduates emerge with skills in complex problem solving, in critical thinking, in creativity. They are capable of understanding the dynamics of complex systems, are skilled in advanced mathematics, and are skilled in interpreting data. All skills which the World Economic Forum has identified as being critical to employees of the future. You can learn more about our physics degrees in our longer videos, as well as a longer video on the careers and career progression of Trinity physics graduates from all 4 of our degrees, which are available on the website. So I'd like to invite you, everybody here, choose to be one of our physics graduates. More information on our webpage and in our Q&A sessions following. Thanks very much.